Okay, so I think it's 2:28 now. So we'll start the session by 2:30. So is Vaibhav there in the call? Vaibhav, are you there in the call? So total how many are there? Gokul, while we are giving the session, so at some point just keep taking some screenshots
Sure,
because
sir.
this we'll have to share with the Techfest IIT Mumbai.
Yes, sir, sure.
Okay.
Sure, sir.
And yeah, so I think we have close to 1 second, just let me check. Close to 30 to 35 participant. 1 second. How do I minimize it? Okay. Okay, I think we have close to 45 candidate who has registered for this. So, so Gokul, how many participants do you see in the call?
Sir,
13.
just a minute, sir.
Uh, yeah, I see total count of 13, out of which I think one and two are us only.
Yeah,
And
three. Yes, sir, three members.
then, yeah, Niranjan are
Mm,
also us. So, out
10.
of 45, we have only 14 here. So, we'll wait for a few more minutes before we start. So, you are able to see my screen?
Yes, sir. Yes.
Okay. No, here it is. How do I maximize this? I don't know. How do I maximize this thing? Because in my window it is showing very small.
Which one, sir? Presentation?
Yeah, not presentation. The Zoom window.
Sir, there will be a tab symbol. like a window symbol will be there, sir.
One second, yeah, let me see. Okay. Okay, I think it's time now. So we'll start. So one second, just okay. So we'll start now. We will start with introduction, and by the time other people want, they can also join in the meantime. Okay. So a warm good afternoon to everyone who is present here. So this workshop is in collaboration with Techfest IIT Mumbai. So uh, I am Pratik Kumar, who is going to present during the workshop, and I have my friend here Gokul, so who will be briefing you about the rules of the competition for the Techfest IIT Mumbai this year. And we are from company called Pinwheel Robotics and Pair AI and Robotic India Private Limited. So at Pinwheel Robotics, our aim is to create DIY and educational learning kits, which will be used by the student community. Peer AI and Robotic India Private Limited sets up the robotics labs in the schools and colleges, and they work on the cutting edge technologies on AI and IoT platform. So we are based out of Bangalore, and this year we have collaborated with Techfest IIT Mumbai to conduct the robotic workshop for the different schools and colleges. So at the end of this workshop, you should be able to have a fair idea about what is robotics, how can you build robot for the competitions, what are the good practices that you should follow while building robots, what are the steps for debugging a robot, how you program the robot, and what are some of the key points that you should keep in mind while you are making or creating a robot. So that is the aim of this workshop. Also, the aim of this workshop is to excite students in participating in these kind of events, because these kind of events is now very much required. Because if you are if you read the news daily, then you must have seen 2 days ago in the Times of India newspaper, one article came where I'm not sure about the number, but around 2 million engineers are going to get graduated this year, but out of which only 30% to 35% are going to get a job. The reason being that the type of education that we students have, we have to upskill ourselves with the latest technologies, and that cannot be guaranteed just by the mere learning that we get in the schools and colleges. We have to take part in these kind of competitions and in the STEM learning. So STEM is called science, technology, engineering, and mathematics, you are not uh, where you are not just concentrated on your branch of study, but you have to open up and you have to basically see the culmination of different branches of engineering, how you can bring together to create some wonderful products. So having said that, the most of the important branch of engineering which need to be whose knowledge everyone should have is like of course computer science, electronics, mechanical, and apart from that, if it let's say some domain specific, then chemical engineering, civil engineering, etc. So the robotics opens up that platform. So when you build any robot, when you work on any project on robotics, right, so you not only work on one part of it, you work on the complete full stack of building a product. That is like uh, uh, starting from coding to electronics to the mechanical design. So everything becomes very much important when you learn robotics. So it is my understanding that after this workshop, you all will be excited enough to actually participate in Techfest IIT Mumbai. And this is one of the most prestigious Techfest that you will ever see in Asia actually. So it is one of the largest one of the largest Techfest that happens. And you should be there in Mumbai to actually experience these workshops, the kind of energy, the kind of enthusiasm that you'll see here. So yeah, so this is all about the excitement which I want to bring in you about the robotics. So pay attention to what is going on in the session, and I think you will all be excited and delighted to learn about it. Yeah. So okay. So about the TechFest IIT Mumbai. So I will ask Gokul to brief you about the TechFest IIT Mumbai and then brief you about the different competitions that we have this year. So over to you, Gokul.
Yeah, thanks, sir. First of all, good afternoon to everyone. So myself, Gokul. So here we are seeing this Techfest. So it is an annual technology festival organized by IIT Mumbai, and it's like an Asia's largest college festival. Okay, attracting some participants over the globe, and so the event typically have a lot of competitions and then workshops, lectures, exhibitions, performance aimed at to promoting the technological innovation and solutions. So the key highlights are competitions. So the competitions can be like a hackathon and coding challenges and other tech-based contests. So this helps to showcase the participant skills. Yeah. So next workshops. So this
ಈಗ
workshop is
ವರ್ಕ್ಶಾಪ್ ನಡೆದಿದೆ ನೋಡಲ್ಲ ನಿಂಗ್ ಕಳ್ಸಿದ್ನಲ್ಲ
uh,
ನಾನ್ ಮರ್ತೋದ್ ನಾ ಟೈಮ್ ನೋಡ್ದೆ ಓ
Anushri.
Anushri, I think okay, I'll mute her. Yeah.
Okay. So coming to workshop, so workshop in the sense it includes a machine learning, blockchain, and robotics, whatever we are having, and providing an hands-on experience over this workshop. And coming to lectures and exhibition, it's like a renowned speakers from the academic and then industry science sharing their insights on cutting edge technology. So all these things we are having in the TechFest. Yeah. So that's it about this TechFest IIT Mumbai. So yeah, you can just participate in this and you'll be getting a lot of ideas over this workshop. Yeah, thank you.
Okay, so I anyway provided you a brief introduction about the Pinwheel Robotics and Pair India. So just to reiterate, so Pinwheel Robotics is a Bangalore-based company specializing in the design and development of DIY robotics kit aimed at promoting STEM. So that is science, technology, engineering, and mathematics. So we provide a hands-on learning experience through our innovative products, which helps students to explore robotics and engineering concepts by building projects themselves. Pinwheel, so about Pair India. So Pair India, as I told you that Pair India is setting up labs in various schools and colleges on robotics, 3D printing, AR, VR, and AI and IoT. So these are the very much required skills that will be there in the next decade. You will need to get a job to get employable, because now it is no more that you work for a company. It is more no more uh, what new products you can bring to the table, and that becomes possible only if you have some practical experience about robotics and other STEM based courses. So yeah, so now Gokul will brief you about the different competition that we have this year. So basically we have two competitions, Cosmo Clench and Mesmerize. So Gokul, you can explain the rules of these competitions and what the competition is about.
Yeah, that's sure. So in this TechFest, we'll be having two things like Cosmo Clench and one more is Mesmerize. So first, seeing Cosmo Clench, so it's a robotic competition. So in this, it's like an arena. So here you will be having some particular task. So you'll be having a bot. Which is like a manual control or wireless control. Anything is fine. So in this, there is a gripper bot. It is going to pick something from that arena and it is going to place it in the target. So this is the task it is going to do. And yeah, so sir, can you show that arena once, sir? Sir, I think it's in my drive. I'll put in the chat, sir, that link. Hello. Yes. Thank you, sir. I can see. So here you can see that arena. Yeah. Yeah. So the bot which we are building is going to run here, and there will be some simple task like from starting from first stage, and so to next stage there will be a object and it has to pick it and it has to put it in the some places, target places. So this is the rule of this project. You have to control it manually, or you can control it like wireless also, not a problem. There will be like some rules for this, and the arena dimension, everything will be mentioned in the rule book. And then, so can you please come down? Second page. Second page, second page. Yeah, so this is the view of different view of the arena. So you'll be having certain tasks and some hurdles over this, and you have to cross this and you have to complete the target. Yeah. So this is what, and here you can use a switch, or you can use a wired switch or a wireless control. You can use both the things. You can use. It's up to you. And so if you're using a wire thing, so it will be around 2 meters. You can just have it, and the power supply, it's like 24 volt max. You should not use that AC voltage. So you can use this like a 24 volt DC. You can use. Yeah. So this is what, and the gameplay they have mentioned here. You can go through this. This is available in the Techfest website. You can go through this. You'll be getting a lot of ideas in it. Yeah. So
So
this is called Cosmo Clench.
yeah.
Yeah.
So these rules you can actually go through it, and then you will already have our email ID. You can, if you have any problems or any doubts on that, you can ask us on the email, or we can set up a follow-up meeting also, where we can clarify your doubt regarding the rules of the competition. So the basic idea of this workshop is to get you familiar with like what the competition is about, and then you need to go through the rules, and we will also tell you about how you can build a basic structure for the robot. So yeah, so this is the basic idea for this event. Now coming to the Cosmo Clench. So I'll sorry, Cosmo Clench is done. We'll come to this one,
Mesmerize.
Mesmerize. Just let me open the Mesmerize. So while I'm opening that one, so Cosmo Clench is a manual control robot that you have to make. In Mesmerize, you have to make an autonomous robot. So okay. So this is about the Mesmerize. I'll go to the arena. Yeah, Gokul, you can explain.
Yes, sir. So Cosmo Clench and Mesmerize is different actually. So Cosmo Clench you can operate manually, but this is completely autonomous. So this is nothing but a line follower robot you have to build, and this is kind of a maze thing. So it has to follow this white line, and it has to take some particular decision when it is going to turn. So these things we have to code it accordingly, and that bot has to follow this thing, and it has to complete the arena.
Okay, so the mesmerize has a second part of it. So one part, as Gokul has explained, that it has to follow the line, and from the start position it has to go to the end position. So this one that you see here, so this is the start position and this is the end position. The other thing, so the second round, what it has to do, it has to take the shortest path to reach the end position. So how will that be achieved? So the person whose robot takes the shortest time to reach the end will be the winner for the competition. So yeah, so more on this later. Before that, we'll start with our uh, theory of the robotics and also some practical example on that. So let me again share the slides to you. Okay, so I think we were on Cosmo Clench done, Mesmerize done, classification of robot. Okay, so before starting the session, so I want everyone's active participation. So I know that it's a post lunch time and many of you may be feeling sleepy, but yeah, do some kind of a movement exercises, like you can stand and sit down for a few seconds. That will give you some energy, and then you can better concentrate on that. So yeah, so before starting with the classification of robots, so I'd like to know like how many anyone can unmute and say I'm going to ask you questions. So uh, what do you understand by the term mean by the word robot? So anyone can unmute and tell about it. I want to make this session interactive, so I really want feedback from you, because if I don't get any feedback from you, and if me and Gokul is only speaking continuously, then we will lose our energy. So you guys have to be in sync to keep our momentum high. Anyone? Can I request some of you to turn on your camera if possible? See, I really want you all to be interactive. Otherwise, it is very difficult for us to run a session like this. It is like a monologue. We keep speaking. I don't get any response, any feedback. How will our instructor be able to communicate? It's a virtual session. We need your response. Okay, I'll randomly select some name. Meghna. So, Meghna, can you tell me what do you mean by robot?
A humanoid robot is a robot that assembly with human body shape. I
Okay.
think
Yeah, fine. Thanks, Meghna. That was really nice of you to give. Yeah. So coming to this thing, classification of robot. So I will not spare much time on these things because these are much more of a theory which you can anyway be able to know. So there are three classifications we can do: manual controlled, autonomous, and hybrid. So hybrid is a humanoid. The Meghna what explained now. So that is mostly a humanoid robot. So in a manual control robot, basically it is like we give the command to the robot through a remote control, and the robot performs the actions accordingly. Autonomous robot is the one which is able to make decision on its own. So by way of various sensors attached to the robot can understand its surroundings, and then it can take some actions through the actuators. So actuators are like the motors and the gears connected to the robot. So the Cosmo Clinch competition that we have, so that is basically a manual control robot. So there you have the option that you can either control the robot through a wired remote control, or you can also control through a wireless remote control. So if you're going for a wired remote control, so you will need to make use of DPDT switches. I'll explain you like how the DPDT switch functions. And if you're going to make use of a wireless remote control, you will have to make use of something like a motor driver. So I'll explain you that as well. So in terms of a wireless control, you can either choose RF, Bluetooth, or Wi-Fi to control your robot. If you're going for a wired remote control, so obviously you'll use the wire as the medium of communication between the robot and the remote. Now, coming to like what does the robot consist of? So, I will ask someone. Okay, Akash. So, Akash, can you tell me what does the robot consist of? What is the basic thing that a robot should have?
Drivers, sensors,
Okay.
motors.
Correct. So motors. So yeah, so that is one of the most important thing that any robot should have, the motors, because a robot is something which has to do some work, right? And these some of these works are like moving from one place to another, picking some object from one place to another. So all of these things will require some kind of actuators. So the most common actuators that we have in our world is the motor. So motor is the one thing that will require. Now, if you would have seen the track of the Cosmo Clench, so what we know is that the robot has to move from one place to another place, and in between it has to cross many hurdles or a different kind of a path, right? So in order to move between in these paths, the robot will need motors with the wheels connected to move in the path. Now what happens is that you have the motors, okay, and these motors can rotate in a clockwise and anti-clockwise direction. So you have to make your robot move in basically four different in multiple different directions, but the four the more common one, that is the forward, backward, left, and right. So in order to make the motor robot to go forward, backward, left, and right, so we make use of a concept called a differential drive. So in a differential drive, what happens is, so let me just open a whiteboard and show you that thing. One second. So everyone is able to see the whiteboard? Okay.
Yes, sir, we can see.
Yeah. Okay. So what basically happens is that uh, let's say you have a one second. Okay, so let's say you have a robot body, okay, and you have one wheel connected here and another wheel connected here. Okay, so now in order to make this robot go forward, the robot should go forward, right? How will the wheels should move? So these wheels should be moving in a this direction, and this wheel should also be moving in this direction. Then your robot will go forward, correct? Now, let's say you want to make a robot to turn right, left, this direction. So what should happen is that one thing that you can do is that you can stop this robot, stop this motor, and let it move only in this direction. So what will happen? Your robot will start turning left. Similarly, if you want to make a robot to go right, so what you can do is that you can stop this motor, but you can make this motor run. So what run in this direction. So what will happen is that this robot will start going to the right. Similarly, if you want to move your robot backward, you can reverse the direction of both the motors. You can reverse the direction of both the motors, and then the robot will start going to the backward side of it. So this is called as a differential drive in terms of robotics. So why differential drive? Because both the motors, so the motor 1 and the motor 2, two motors connected, motor 1 and motor 2. So these two motors, if you change the direction of these two motors, if you change the direction of these two motors and make various combinations, your robot can turn in a different direction. So I'll tell you how you can do that. So basically now it's a question from you all that yeah. So I'll make one table here, and this is the motor 1. So motor 1, let's say going in a clockwise direction, and motor 2 is also going in a clockwise. Motor 1 clockwise, motor 2 counterclockwise, motor 3 counterclockwise, this one clockwise, and both counterclockwise. So now you say me, if both are rotating in a clockwise direction, the robot will go forward. One is counterclockwise and one is clockwise. The robot will take either left or right. Similarly here, either right or left. And if both are rotating counterclockwise, then it will go back. So this is something, this is the concept of a differential drive. Got it right? So you can give a hands up if you understood this logic concept. Okay, so I think I have to explain once more. Okay, let me try to illustrate in a better way then. So what I meant basically is that you have one motor here which is going in a forward direction, one motor here which is going in a reverse direction. So can you imagine what will be the motion of your robot? So let's say this is the robot body. This motor has a tendency to go forward. This motor has a tendency to go backward. So what will happen to the robot? The robot will start spinning, right? Are you all agreeing to this thing? If yes, you can give a hands up. Okay, I see one hands up from Pavan. No, okay, Sanjana, Rachna. Okay, okay, okay. So I think that you are able to follow this thing. So similarly, if let's say if both of this has a tendency to go forward, then your robot will be moving forward. And the other thing that can happen is that one has the tendency to go forward whereas the other is stopped. This one is stopped. So what will happen? This will start turning this side. Similarly, if my this side motor is stopped, but this side motor is moving, it will start turning this side. So this is your right turn, this is your left turn, this is your spin, and this is your forward. And in order to go reverse, it is just opposite. Both has a tendency to go backward, and it will be reverse. So this is the concept of a differential drive. Now we'll see how we can achieve this thing. Okay. So now how we will achieve this thing. So this thing is being achieved by activating one or different motors in a different direction. So that we'll see now in the second slide. So this is the differential drive mechanism. Okay, so this we will be able to achieve by the help of a DP-DT switch. So I will explain you how the DP-DT switch will function. So once again, let me open a whiteboard. So in Zoom, actually, it is very difficult to switch between whiteboard and presentation. That's why it is taking some little more time. Okay, so basically, what happens is that so you have a motor. So in any motor, two terminals will be there. That is called plus and minus, positive and negative terminal. Now, if you connect the positive terminal of the motor to so let's say this is your battery, okay, and this is the positive of battery, this is negative. So if you connect positive of the motor to a negative of the battery and the negative of motor to positive of the battery, the motor will rotate in a counterclockwise direction. So this is applicable for any kind of a your this thing any kind of a DC motor. If you reverse the polarity of the battery, that is this side it becomes plus and this side it becomes minus. So what will happen? The motor will start rotating in a clockwise direction. So now you think of that you have to control a robot where you have to change the direction of the motor. How easily will you be able to change the polarity of the battery? How can you change this polarity of the battery easily? So the one way is to do is that you take out the battery and insert the battery in a reverse way. But is that feasible? Is that practical? Is that practical? Mrityunjay, is that practical? That you take out a battery and reverse the polarity of the battery? Mrityunjay, you can unmute and tell me the answer. Okay, anyone else? Nandini? Nandini? Okay. S- So the thing is that it is not possible for us to change this polarity of the battery while the thing is working. So we have to make use of something called as a DP-DT switch. So DP-DT switch. So in a DP-DT switch, what happens is that you have six terminals: one, two, three, four, 5 and 6. And in any switch, you know how the switch functions is that when the switch will be turned on or off, these terminals will get connected or these terminals will get connected. So any of these terminals will get connected at once. Let me clear the screen. So any of these terminals will be connected. So in a DP-DT switch, what you have is a six terminals are there. And what we do is that we have a battery. In the battery, one plus and one minus will be there. And then let's say we have one motor. In the motor also one plus and one minus terminal will be there. So what we do is that we connect this plus terminal here, we connect the minus terminal here. For the battery, we connect the plus terminal here, and the minus terminal we connect here. Okay. So now when we turn on, means we put the switch in this position. When we put the switch in this position, what happens? These two terminals get connected, and these two terminals get connected. So when these get connected, the plus of the battery is going to the plus of the motor. The minus of the battery is going to the minus of the motor. So which direction the motor will move? The motor will move in a clockwise direction, right? Now we have to reverse this direction. So what we do is that we take a wire and we cross connect this and this terminal. So now when we put the switch in this position, so what happens is that this and this terminal gets connected, this and this terminal gets connected. So what happens? The plus of the motor is going to the minus of the motor. Sorry, plus of the battery is going to the minus of the motor, and the minus of the battery is going to the plus of the motor. So which direction the motor will move now? Counter clockwise. Correct. So this is the concept of a DPDT switch. Now you can make use of two such DPDT switch. You can make use of two DPDT switch to control two motors. So if you will be able to control two motors, so you will be able to make your motor move in a forward, backward, right, left, stop. So these motions you will be able to achieve. So this is about the DPDT switch. Now coming to so this is how your DPDT switch will look like. The black color thing that you see, and as I shown you, 6 terminals will be there. So you can make use of this 6 terminals to make your robot move in a different direction. Okay. So in the Cosmo Clinch competition, you must have seen there is one thing that we need to do is that we need to move pick object and place it into another place. So how will you pick and place the object? So what you can make use of, you can make use of a robotic gripper. So this robotic gripper will be able to actually catch the object and then move it around, and then wherever it is required to be placed, it can release the gripper so that the object can be placed there. So now I will request Niranjan, who is also from Pinwheel Robotics Pair AI Robotics. So he will show you a demo of how a robotic gripper works. So Niranjan, you can turn on your camera and
So,
you can show the demo.
yes. Can you see, sir?
Yeah, 1 second. Let me see if I can put you to spotlight so that everyone can see. Yeah, spotlight for everyone. So everyone is able to see Niranjan's camera, Niranjan's video. Okay. Yeah. Yeah, Niranjan, you can show this thing. So what you are going to see now is that Niranjan has made use of the DPDT switch only to rotate the motor in a clockwise and anti-clockwise direction, and that is actually helping the gripper to open and close. So you can see that with the help of a DPDT switch, he is operating rotating the motor in a both clockwise and anti-clockwise direction. When it rotates in a clockwise direction, it closes the gripper. When it rotates in the anti-clockwise direction, it opens the gripper. Got it. So I think this will be able to give you a clear idea about how the DPDT switch functions and also how the gripper will function. So you can use this type of a gripper for your Cosmo Clinch competition. Yeah. Now coming to the next part of thanks Niranjan.
Yes, sir. Thank
Yeah. So now coming to the next part of one second. Coming to the next part of this thing. So this is about the manual control, that how we will be able to control the motors manually by way of a DPDT switch. But most of the time when you're building an autonomous robot, or let's say you are building a robot where you need a wireless remote control, so that is the time your motors will not be directly connected to the switch. So you will need some kind of a automation to basically control your motors. So for that purpose, the one thing which is very closest to the DP switch, that is called as a motor driver or differential drive. So in a motor driver or a differential drive, what happens is that whatever currently we were controlling the motors by way of a manual switch, that thing is being done by way of a electronic switch. So through by giving an electronic signal, the switches actually turn on and off in different direction. So that is how the differential the motor driver works. So a typical pin diagram for any motor driver will be like this, as it is shown on the slide. So what you can see is that input 1, input 2. So this is the input signal where you have to give the signal, and the output 1 and output 2 will be connected to your motor 1. Output 3 and output 4 will be connected to motor 2. So this differential drive, you can this motor drive you can actually control two motors at once, and this is the type of a driver module circuit that will get in the market. So these blue terminals that you see on the left and right of it. So here you can connect your two motors. This three terminal blue connector that you see here, you can put a power supply here, and this is the driver, the black one, the large one that you see here with a heat sink. So this black thing is called a heat sink. So this is the driver here. So this actually operates it, and these are some of the supporting circuit that it has in order to run this driver. So this is how it happens, and these pins that you see here, so these are the pins where you have to give the input signal. So based on these input signals, your motors will either move in a clockwise, anti-clockwise, or stop. So that is how. So input 1, input 2. Let's say if input 1 and input 2 both are high signal, then your motor will be stopped. If input 1 and input 2 both are low signal, then also your motor will be stopped. So you need a differential input in order for the motor to work. So let's say your input 1 is high and input 2 is low. So that is the time your motor will go in a clockwise direction. If your input 2 is high and input 1 is low, it will go in a counterclockwise direction. Similar case for the input 4 and input 3 for your second motor. So, any doubt with the motor driver? Okay, if you all don't have a doubt, then I have one question from Sushma. Okay, Sushma. So, can you tell me what do you mean by a high and low signal? Sushma, can you unmute yourself?
No, sir, I don't.
Okay, so high signal means that in any kind of a electronics, right? So you have a two signal that is called as a high signal and low signal. So high signal corresponds to the logic of 1 and low signal corresponds to the logic of 0. So all the electronics, right, that work on a digital world. So in a digital world, you have only two signal, 1 and 0. So high is your 1 and low is your 0. So basically in terms of voltage, if you say, so let's say if you have a device which works on operates on a 5 volt voltage. So what it means that anytime when it requires that signal should be given high, you should know that the potential of that particular pin should be plus 5 volt. And if it is low, it is going to be 0 volt, and that is ground. So that is the meaning of high and low signal. Okay, so this is what I was showing you. So you can go through that this slide. So this is how you'll connect your two motors, and then you can program your Arduino board so that you can give the signal here. So even means like we'll go to the programming little bit later, but this is just for your understanding like how the motor driver will work, because these are some of the basic things that you will use when you are building robots for the competition. Okay. Okay, so this is all about the Cosmo Clench. So next we'll move to the autonomous robot. So this was about the manual robot. So in a manual robot, how you will control motors, how you'll use the switches, or if you want to go for a wireless thing, how will you do that? So this is the basic thing that is covered. Obviously, in a 2 hour session, all of these things cannot be covered because robotics is a very vast field of study. If you are really interested, you can go through internet and you can read some articles, and then you can come back to us for some additional questions. But yeah, this is just to give you an insight about like how will you make your first robot. So how many of you here have made any robotics project? Can you raise your hands? So how many of you have previously made some project on robotics? So you must have already have idea about this thing. No one? Okay, no problem. So I think it is a very good platform for you now, this TechFest. So I would really want that all of you should participate in this event because that will help you to understand about robotics and how to build. Don't worry about whether you are able to make it or not make it, but the thing is that if you try something, you will be able to make and learn the learn the concept about it. And believe me that this is going to be very much useful in your study as well as while securing career. Okay, so now coming to the Arduino and Arduino IDE. So before coming to this, so what I would like to say is that in any kind of a autonomous robot, what we want is that we should be able to program the robot. Like we should be able to tell the robot what it has to, not tell the robot. Basically, the robot should be able to judge itself what it has to do. Okay, so in order to do that, you have to put some program in the robot. So where you will put the program? So there is something called as a microcontroller. So where you can actually program the controller. So based on the different sensor input, it can give the output like what it is supposed to do. So one of the most common thing that all people who start with robotics and any electronic autonomous automation project, they start with Arduino. So Arduino is a very much a very common platform and it is used across the world for building a lot of prototypes and a lot of projects. So yeah, I will give you a brief. So what you can do is that you can go to the arduino.cc website and you can see that this is an open source hardware platform where you can program your robots and your any automation project you can program using Arduino. So what does Arduino consist of? So so there are in any kind of a microcontrollers what you have a general purpose input output pin. So this general purpose input output pin, what it means is that in order to give the signal, as I told you about the high and low signal, right? So how will you give this high and low signal to the driver? So what happens is that in these microcontrollers you can drive the pin. So multiple pins will be there in the microcontroller. You can drive the pins to either high and low. I think I will better explain you on a whiteboard. So let's say this is your microcontroller. Microcontroller. So these microcontrollers will consist of various pins. So various pins will be there. And these pins, some of these pins that are called as a GPIO pins. So that is general purpose input output. So these pins can be driven high or low. These pins can be driven high or low. Now you had the motor driver, right? So the motor driver, I told you that certain pin, if you give high and low signal, then you will be able to control the motor in a clockwise or anti-clockwise direction. So what happens is that 1 second. So this is your microcontroller. These are the various pins. this is your driver, and this is your motor. Motor is connected to your driver. The driver pin is connected to your microcontroller. Now this microcontroller, you can make the pin either high or low through a program. So you will have a program running here. Now through a program, you can make your pin high and low. So let's say your program makes this pin high and this pin low. So let's say your program makes this pin high and this pin low. So what will happen? The driver will get a differential voltage here, and it will help the motor to run in a clockwise direction. Let's say example, it will help the motor run in a clockwise direction. Now let's say the same program after 5 seconds it makes this pin low and this pin high. So what will happen is that the motor will turn the direction. It will now start rotating in a different direction. So this is how you will be able to control it. So how you will be able to do that thing? So in your program, what you will do is that you will keep A is equal to high, B is equal to low, and after 5 seconds, so you will give a delay. So let's say you give a delay of 5 seconds, that is 5000 millisecond, and after that, what you will do is that you will make A as low and your B as high. Okay, and so this pin will change the voltage here, and your motor will start rotating in different direction. So this is how you will be able to control the speed, the direction of the motor by way of a program. Now let's say, as I told you, GPIO, right? General purpose input output. So this time your pins are in the output mode. Why it is in output mode? Because you are able to set the state of the pin, high or low. So you are giving the output. So your motor is the output device. So this is output mode. Now similar thing. Now let's say what you want to do is that by way of a proximity sensor. So what does a proximity sensor do? Proximity sensor sees whether any object is there in the proximity or not. Now let's say I have a sensor. Let's say I have a sensor which is able to see whether any object is present here or not. So if the object is present, the sensor will give the value of 1. If the object is not present, it will give a value of 0. Okay. So what I do now, I connect this sensor to one of the pin. Okay, to one of the pin in the controller, and I define that pin as an input pin. Now what I will do, instead of writing a delay here, where I was manually changing the direction, what I will do is that if let's say object is present, then move in a clockwise. If object is not present, then move in an anti-clockwise direction. So what I will do, so now how my program will change? So now instead of this, my program will become like this. If so, let's say the pin where the sensor is connected, if is C, for example. If C is equal to high, if C equals to high, then make A equals to high and B equals to low. But else, if C equals to low, that is no object is there, then make A equals to low and B equals to high. Got it? So this is how you will be able to control the direction of the motor based on the input from the sensor. And this is the role of a this thing microcontroller to help in programming the module. So hope would have made you understand about the pins, that is the general purpose input output pins and the digital signal. So in terms of Arduino, we have total 14 digital pins from pins D0 to D13. So that can be configured as either input or output. And we have digital states as high and low, which I already explained. Working with digital pins, I explained in a whiteboard. So this is like that. And now coming to the, so before I move to the analog pin, I would like some hands up that if you would have understood about digital, because if you have not understood digital, then it will be very difficult for me to make you understand about analog. Okay, so Meghna has raised the hand. So Meghna, you have any doubt, or it means that you understood the concept?
No, sir, I don't have any doubt.
Okay, okay, Meghna, good. So anyone else had any doubt on the digital? Any doubt related to
Uh,
digital pins?
Hello, sir.
Yeah, yeah,
Sir, I'm Samiksha. I had a small doubt in this,
yeah,
sir.
yeah, please.
Sir, you said that if we enter more amount of input to one of the terminals, it would run or it would operate in clockwise or anti-clockwise direction.
Correct.
Sir, will that be marked on those pins or what, sir? Like, how do we get to know that if we apply large amount of voltage or something to this signal, it
Okay,
runs clockwise?
okay. So Samiksha, first of all, thanks for asking question, because that actually gives me a good feedback that people are following the instructions that we are providing. So yeah, so now coming to your question. So the thing is that when we say a large amount of voltage, I actually did not mean large amount of voltage. What I meant is that high is always terminal large voltage and low is a low voltage. So large voltage is like every device has a biasing voltage. So that is like the device data sheet will give you like what is the maximum voltage it supports. So Arduino kind of a device normally works from 0 to 5 volt. So 5 volt is the maximum voltage. So what you need to do is that whenever you are supplying a high voltage to that pin, so you have to make sure that your voltage should not go beyond 5 volt, because if it is going to go beyond 5 volt, no, you will damage the microcontroller. So you have to make sure the sensor that you are going to use, right, that sensor produces a maximum 5 volt. It should not give a voltage which is beyond 5 volt. Did I answer the question?
Sir, I got to know that, but my question was like how do we get to know that it is working in clockwise or anti-clockwise direction?
Okay, so clockwise and anti-clockwise,
Uh,
you can physically see the motors. You can physically see how it is rotating.
Sir, like to which terminal I should apply? Sir, there will be
Correct,
two
correct. So
terminals, right?
yeah,
Like,
so basically a general rule, as I told you previously also, a general rule is that in your motor terminal it will be marked as plus and minus. Sometime it will be marked a red dot. So red dot is a plus and the other one is a minus. So normally it will be marked plus and minus. So the plus thing, if you give a high voltage to the plus and low voltage to the minus, your motor will go in a clockwise. If you reverse it, it will go in a anti-clockwise.
yeah, sir. Thank you.
Yeah, thanks, Amiksha. Okay, so now since we have already understood the concept of the digital pins. Now we'll move to the concept of the analog pins. Now, why analog pins, and what is the difference between digital and analog? Can anyone tell me what is the difference between digital and analog?
So digital language is in terms of zeros and ones. It is binary, but analog we have numbers, sir, like integers to say it as a whole.
Okay. So yeah, you are partially correct. So digital is 0 and 1, that's right. And analog, what you are saying is also correct, that it can range from one number to another number. So let's say you have the high voltage at 5 volt and a low voltage at 0 volt. So the analog voltage can be anywhere between 0 and 5 volt. So normally in the digital case it will be 0 volt or 5 volt, but in analog it can be anywhere between 0 and 5 volt. So yeah, so now why analog pins? So the thing is that most of the time in the actual world, when you see the sensor, right, in terms of the obstacle sensor that have shown you, so there the purpose was to whether the obstacle is there or not. So it's a binary thing. Either the obstacle can be there or the obstacle cannot be there. So it is only two states, 0 and 1 are there. But then there are many different kind of signals in the environment, where it is not only the presence and absence of an object, but it is also about like how much object is there or how much value is there. So for example, take a case of a thermometer. So in a thermometer, you don't have only two temperatures, 0 and 100 degrees Celsius, but you have so many temperatures in between, right? You have so many, from 0 to 100 degrees Celsius, you have so many temperatures. So now let's say you want to measure accurately what is the temperature at this particular point or at this particular point of time. So that is a you cannot say it is either 0 or 100, but you have to say something in between, like 32 degrees Celsius or 48 degrees Celsius or 43 degrees Celsius, something like that you have to say. So these are the some of the parameters which you want to measure, which are analog parameters. So this you have to measure using the analog pins on Arduino. So I can tell you more details about the analog pins on Arduino. But I think for now, the scope of this presentation is only limited to like where will you use the analog pins and how will you use the analog pins. It is not related to how the analog pin functions, but anyone who is interested in learning about like how the analog pin functions, go through the concept of ADC, that is called as analog to digital conversion. So every microcontroller will have some one or two channel of ADC in it, and that ADC actually helps in converting your digital signals to an analog signal. Okay, so please take note of this thing in your notepad or somewhere, ADC, or I'll also put it in the chat so that 1 second, so that you can. Okay, so anyone who is interested in learning more concept about it, they can go through the concept of ADC, that is analog to digital conversion. Now, coming to so the focus of this presentation is actually on the how will you build a mesmerized robot or how will you build a line follower robot. So my scope will be limited to that only. Yeah. Now, till now, what you have seen is that you have seen about the control of a motor in terms of direction. Correct. You have seen that how can you control motor in a forward direction and a reverse, sorry, in a clockwise direction and anti-clockwise direction. Till now, we have not seen like how can you control the speed of the motor. So here comes another concept. How can you control the speed of the motor? So why speed of the motor? So can anyone tell me why do we want to control the speed of the motor? Why do you want to control the speed of the motor? Okay, I'll tell you. So basically, when you drive a car, do you drive your car at a constant speed? Let's say 80 kilometer per hour, always. You have to control the speed of the car, right? You cannot drive always at 80 kilometer per hour. If there are some other vehicles on the road, you have to slow down the speed. On a turning, you have to slow down the speed. On a U-turn, you have to slow down the speed. On a highway, you have to drive faster. Maybe you go 100, 120 like that. Okay, so that is the reason why you need to control the speed of the motor, even in terms of robotics. So how will you achieve this thing? Because you make so if you go to buy motors in the market, right? So you may get a 100 RPM motor, 200 RPM motor, 300 RPM motor, or a 50 RPM motor. So these motors are rated at a constant RPM, but you need to control the speed of these motors. So how will you control the speed of the motor? So before going to that thing, can anyone tell me what do you mean by RPM? Can anyone tell me what do you mean by RPM?
Rotations per minute.
Yeah, Akash. So yeah, rotations per minute. That's right. So even in your motorbikes and your car also, you would have seen your engine RPM will be there, right? So 2,000 RPM. Sometimes it runs at 1,000 RPM, 500 RPM like that. So it is rotations per minute. So basically, it is like how many rotation does your motor make in 1 minute? So when we say 100 RPM, so what it means is that it makes 100 rotations per minute. Now from your rotation, can you calculate the speed of your motor?
Yes, so
Yeah, how will you do, Samiksha?
set the number of rounds into distance travel divided by time.
Exactly. So it will depend on the radius of the wheel as well. So with any motor, you will connect the wheel. So from the radius of the wheel, you will be able to find the perimeter of the wheel. So that perimeter is like, let's say the perimeter of the wheel. So I'll not go into the final calculations, but I'll just say, so let's say the perimeter of the wheel is 10 centimeter. So what it means is that in one rotation, your wheel will move 10 centimeter ahead. Correct?
Yes.
Yeah. So this is how you will be able to find the speed of your robot also. So now coming to how you can control the speed of your motor programmatically. So there is a concept called as a PWM. So before going to the PWM concept, I will tell you how the speed of the motor is dependent on the voltage applied to the motor. So let me again open a whiteboard to explain you this thing. Okay. So what happens is that your motor speed is there, and then you have a voltage. So let's say your motor is rated at 12 volt, 300 RPM. So what it means is that if you will apply 12 voltage, 12 volt to the terminals, to the plus and minus terminal, then your motors will be rotating at 300 RPM. But what will happen if you reduce this voltage to 9 volt? Will it still rotate at 300 RPM? Will it still rotate at 300 RPM if you reduce the voltage from 12 volt to 9 volt? No, it will not rotate at 300 RPM. It will rotate at speed lesser than 300 RPM. And how much less? That depends on one constant factor, that is K. You can take K into 300 RPM. Okay. So this is a concept. So using this concept, that your motors will actually rotate at different speed if you apply different voltages across the terminal. So this is the concept that is also applied in the PWM. So in a PWM, what happens is that, so your digital pins can either be in a state of 1 or 0. Your digital pins can either be in a state of 1 or 0. And what I will do is that I'll write 1 as high and 0 as low. So what it means is that the signal that I am putting here is something like this. So this is 1, 0, 1, 0, 0, 1, 0. This is just an example that I am showing you. So so if you take the average of this, right? So your average voltage will come something like this. So if let's say if you quantize it, then your average voltage will come something like this. Now let's say your high voltage was 12 volt and your low voltage was 0 volt. So your average of this will come something around 9 volt or 10 volt, something like that. I'm not going into the exact detail of that, but I'm telling you that. So this way you will be able to control the speed of the motor. So that is what is the meaning of PWM. So PWM means pulse with modulation. So it basically gives you the average voltages. So so it is measured in terms of a duty cycle. So you can have a duty cycle of 50%, you can have 75%, any value, 25%, 80%, any value you can have a duty cycle. So if it is 50%, what it means is that if your motor is rated at 300 RPM, at 50% duty cycle, it will run at 150 RPM. Got it? So this is the whole idea about this. And there are some special pins in the Arduino, which only those pins you can use for PWM. So these are pins called 3, 5, 6, 9, 10, and 11. So all these details you can get in the internet as well. So pin number 3, 5, 6, 9, 10, and 11 you can use for PWM. So the idea of this is that you should know what is the functionality of this one. So once you have those things, you can create your own recipe, like what kind of a robot you want to make, and what is your requirement. Based on that, you can apply the concept. So now, since you have idea about the PWM, you have idea about the digital pins, you have idea about the sensor, and you have idea about the motors. So now our next task is like, how can you make a line follow robot where it will be able to follow the line? So in order to make a line follow robot, we make use of a IR-based proximity sensor. So the idea is that in a IR-based proximity sensor, two main components are used. So one, this a transparent type of component that you see here, which is hidden halfway, but this is called IR LED, which emits infrared radiation, and this is a photodiode, a black color thing that you see here. So what it does is that the photons, when a photon is bombarded to this particular device, it generates a small current. So by measuring that small current, you should be able to know how much light is falling into this. So we make use of this thing. So now what happens is that when this IR LED emits, so this is arranged in this fashion. So we arrange it in this fashion. So this light blue color thing that you see here, or the dark blue color thing that you see here, that emits an infrared light. So it emits an infrared light, and then it reflects from a surface and comes back to this black surface. And then the black surface generates a small current, and by detecting this small current, we are able to say whether some object is present or not. But in case of a line follower robot, what will happen is that the object will always be there. Only thing is that some object will be painted in black, some object will be painted in white. So now can anyone tell me how will this sensor be able to identify between black and white? What is the special property of a white and black that this sensor utilizes to find whether the line is present or not? Okay. So can anyone tell me what happens when a light falls on a white surface? Does it reflect or it absorb light? When a light falls on a white surface, does it reflect all the light or it absorbs the light?
It reflects back.
It
Correct. It reflects. And what happens when it falls on a black surface?
It absorbs.
It absorbs. So this is the same concept with this sensor utilizes. So what happens is this IR LED emits a light. If it is a white surface, it will reflect back, and that light will fall on the black surface, and it will detect the presence of a small amount of current. But if it is a black surface here, it will not reflect anything, so nothing will come here. So we will know that it is a black surface. So this is the whole idea about it, and this is how it is able to identify between a white and black surface. Excuse me. Okay. So more on this, I can really explain more on this, like how does this whole thing functions, but that will take a lot of time, and we may be able to miss something. But just to tell you, we make use of a comparator. So this comparator, what it does is that we set a threshold voltage, and if the let's say the voltage is beyond that threshold, it gives a high output. If it is a less than threshold, it gives a low output. So that is how you are able to identify whether the black surface or a white surface is there. I think this is one part of it, and we'll continue with some more concept. But I want to give you all a 5 minute of bio break. So if you want to use restroom or something or drink water, please have it and come back. So I'll see you in another 5 minutes. And in after 5 minutes, we'll have some question rounds, and then we'll start with the next session. Okay, so everyone, you can take a bio break, and after 5 minutes, we'll start again. Welcome back, everyone. So I think you all must be energized now. So yeah, we'll take up some questions before we start with the next part of the session. So yeah, please do ask some questions. Anyone on any topic, even let's say if it is not related to the one thing that we have gone through till now. If any general questions on robotics or any general questions on competitions, you can please feel free to ask. Okay, so moving to the next thing. So the next one is little bit more interesting because we'll come to the actual line follower competition, mesmerized competition, how we'll do this. So what is a line follower robot? So a line follower robot is something that follows a predefined line path. So this line path can be drawn in a white on a black surface or a black on a white surface, black line on a white surface. So what is the application of this? The application of this is in most of the factories and the assembly line. They use this kind of a navigation to actually move the robots from one place to another place. So that is called as industrial automation. Then we have some competitive robotics, that is a maze solving robotics, line follow robotics, and all. So where we use this. Now, what are the basic components that you'll need to make a line follow robot? So first of all, what you need is a microcontroller because that is the brain of your computer, which will uh, control the motor and which will also take the input from the sensor. Then you need a sensor, that is the proximity IR sensor. You need motor basically to move your robot. You need a motor driver obviously because you want to control your motors programmatically, so you need a motor driver. And then you need a power supply battery. And also obviously one thing that is not mentioned here is a platform on which all of your these components will be fixed. That is basically called a chassis. How will this be connected? Typical circuit diagram. So this is how a typical circuit diagram will be there. So yours, this is the Arduino board where this microcontroller is there. In that you have two motors connected through a motor driver. You have power supply. You have two sensors here. Now why two sensors? That we'll see later. So this is the basic circuit diagram that we'll have. Working principle, line follower. So your sensor detects the line, sends signals to the microcontroller. Microcontroller make a logic out of those signal what it has to do, whether it has to go left, whether it has to go right, or whether it has to continue straight, and if it has to also control the speed of the motor. Motor response, motors adjust to keep the robot aligned with the line. So that is the thing. Now algorithm for line follower. So this is the very simple thing. So if sensor detects line on the left, turn left. If sensor detects line on the right, turn right. If sensor detects the line in the center, move forward. If no line detected, stop or search for the line. So let me explain you a little bit on this concept. 1 second. So typically what will happen is your in your line follow robot. So you will have, let's say, you have a, so this is your robot, let's say this is your robot, and here two sensors are there. Okay, and this is your line. So this line is in a black color. So I will not draw it, but this line is black color. So now let's say this robot is moving forward. So what happens is that when this robot will come, let's say this position, when this robot will come, So this sensor will be here, this sensor will be here. When this robot comes here, this sensor will be here, this sensor will be. So this sensor will start seeing black, but this sensor will still see white. So what will happen? This sensor will instruct the robot to turn right direction. So the robot will turn little bit right. So what happens is that again this sensor comes here. So similarly means like the robot will keep changing the direction based on the input it is receiving from the sensor. So you can imagine. So let me draw it more better. So let's say this is the line path, and just consider this is a sensor. So this place is a sensor. So let's say it is moving straight. So up to here it will move straight. So now at this point what will happen? At this particular point, think of at this particular point what will happen, that when the robot moves little bit more straight, both the sensor are on a white surface. If both the sensor are on a white surface, it will ask the robot to take a turn. When it take a turn, this robot will find and this sensor will align here. Similarly, this sensor align here, then go here, then go here. Like that, the robot will take a turn. So this is how your typical line follower will work. So this is the same thing that is written here. If sensor detects line on the left, turn left. If sensor detects line on the right, turn right. If sensor detects the line in the center, move forward. If no line is there, stop or search the line. So that is what happened in that corner. So that is about the line follower thing. So anyone had any doubt on the line follower? Because next we'll move to the more complicated thing. So if you are not clear with the line follower, then it makes no point to move to the next one. So anyone had any issues with the line follower? Any problem? Okay, so Salini, can you tell me in a line follower robot, so if your sensor, one of the sensors is detecting a black line, the other sensor is detecting a white, what should happen that time? Should the robot be going straight or it should take a left or right turn? Okay, anyone. If not Salini, anyone can tell me about this one. So if one of your sensor is sensing a black line, the other sensor is sensing a white line. Will the robot should be going straight or the robot should be moving left or right?
It moved towards left or right.
Okay, yeah, that's right. So that is the whole concept of the line follower, that based on the sensor input, you have to take a decision whether the robot should go left, right, or go straight, continue straight. Okay, so now in order to make this line follower more robust and more practical, so we don't make use of only two sensors, but we make use of five sensors. So you can make use of five sensors to detect the absence and presence of line, so that in time it is able to correct the direction of the robot, so that your robot becomes fast and also more accurate. So making a line follower robot is not difficult. You can make it easily, but the most difficult part is like how will you make this robot fast and also accurate? Because some of the time the robot will miss the line and it has to come back to the line. So those things are more complicated. So once you make a basic line follower robot, then you will be able to understand like what all different complications it will have. So the first thing is that make a simple line follower robot using two sensors and then you expand it to five sensors. Now coming to the solving robot. So the maze solving robot, what happens is that along with the line follow robot, what you also have to do is that you also have to find the shortest path. So how will you find the shortest path? So the idea is that let me open a one maze, then I will be able to explain you better. So this maze that you see here, right? So now let's say I am starting from, yeah. So let's say my robot is starting from this position, okay? My robot will start from this position. Now the robot sees a white line, it moves forward. At this position, what will happen is that the robot will the robot sensor. So the sensor will be so your sensor will be like this. Like let's say this is the robot. The robot sensor will be here, right? So here one sensor, two sensor, three sensor, four sensor, five sensor. Let's say. So these five sensors now will see a white line. So all the five sensors in a white line. So what it means that you have reached one junction. So this is called a junction, T junction. So it means that you have reached the T junction. So this is a T junction, right? Everyone is agreeing that this is a T junction. Okay.
Yes,
So
sir.
at this, yeah, so at this T junction, you have to make a decision whether I have to go left or right, because your robot can either go left or it can go right also. Correct. So what we do is that we make a rule. So what rule? So any kind of a problem that you have to solve, right? You have to make some rule. So we make one rule. So what rule we make? That whenever you find a T junction, always turn left. Don't do anything else but turn left. Whenever you find a T junction, turn left. So at this junction, it finds a T, so it turns left. So it goes this direction. Now when it comes to this dead end, right? So all the sensors is a black line. So this place, all the sensors is a black line. So the other rule is that when you see no line, or a black line, when you see no line, so it means that you have reached a dead end. Correct. So at dead end, you always take a U-turn. At dead end, you always take a U-turn. So that is the next concept. So at this dead end, what happens is that the robot takes a U-turn. Now when it takes a U-turn, it comes here at this place, and then this is again what happens is that, sorry, yeah. So at this place, what happens is that again it sees that I have uh, half of the sensor is in black color and half of the sensor in white color. So half sensor is in black and half sensor is in white color. So at this point, what it does is that it can again turn left, but it sees that I don't have any where to go left, so it goes straight. It goes straight, and then again it sees a T junction here. So at this T junction, again what it does is that it has to go left. So it goes left. It comes here, then obviously it has to go here. Again take a U-turn from here, go here, and then again it turns. So this one it passes and go here and then turn left, then turn left, then again take a U-turn, go straight. At this path it will keep going, because it when it sees that there's a okay, so there's only left here, so it will obviously go left, then it will go here like this. Again T junction, it will go left. Again again it will see a T junction, it will go left, take a U-turn, again straight like this. It will take left, go here. So like that it will keep continuing, and it will be able to reach the end, but it will take a lot of time for it to reach, because every time you see that it is taking a U-turn, it goes to the wrong path and it takes a U-turn. But this is how it will be able to do. So every T junction that you go, what you will do is that you will make a note of what direction you went. So let's say you started from this position, you take a left, right? You'll make a note of L. Then you took a U-turn. So U-turn we tell it a B. Then again it goes straight, and then here it would have taken R, right turn. But again it would have reached dead end, again taken left here, here again left. So like this, you have to make a sequence of like what all directions it has done in order to reach end. After that, we'll simplify the thing. So what we'll do is that anytime what you are seeing from this logic, what you're seeing that whenever the robot takes a left turn and then it takes a back turn, U-turn. So what it means, that it's the wrong path, correct? Because this path was wrong. The robot was not supposed to take this path. So what it will do is that the next part of your algorithm, what it will do is that it will simplify this thing. If it sees a left and back, so it will nullify that thing. So you don't have to do this thing. So next time when the robot comes at this junction, the first T junction, what it will do is that it will know that I have to take a right. I don't have to take a left, because left, if I take a left, I have to take a U-turn. So this is how it will simplify it. So what I would recommend, I know that this will be a little bit complicated for everyone. So what I will recommend at this point of time, that you search in internet about LSRB algorithm. I am also putting that in a chat window. So that will help you in designing a robot, LSRB. So there are various different algorithms, but this is the most simple one. Once you are familiar with this algorithm, then you can go for another algorithm that is called as a Dijkstra algorithm. That algorithm is called as a A's algorithm or a Dijkstra algorithm. So a little bit more on this I'll tell you, but first let me do a different share. Let me jump to the PPT. Okay, let me jump to the next algorithm. So sorry, not next, jump to the PPT. My bad. 1 second. So yeah, the algorithm that I explained you now was what's called as a left hand rule or right hand rule. So either you make one decision, you take a left hand rule that anytime you see a T junction, you go to the left, and otherwise you make a, you can do also other way around, that anytime you see a T junction, you go right. So that is up to you which one you want to choose. But both will give you almost same result. Then yeah, once you have done that, then you can also go for these algorithm called flood filling algorithm or a backtracking algorithm. And yeah, so now coming to the, so this is what I was telling about. I already explained this thing. Yeah. So this is the actual logic here. So for each pattern L, any move R. So what it means that if let's say your algorithm is like LBR, so what will happen is that if that is there, then replace the last three moves with a single B block with a B back. So 1 second, this will become a little bit complicated. I should explain you in a, let me think how to explain you in a much simpler way. So you can actually, yeah, what you can do, you can imagine that you are trying to find a place in your neighborhood. You're trying to find a place in your neighborhood and you are stuck in a maze. Think of it this way, that you're stuck in a maze. How will you come out of that maze? So the thing is that how will you come out of that maze? You keep going in the maze. Whenever you see any intersection where you have to go both left and right. So if you will not make any rule at that point of time, no, sometime you take left, sometime you take right, out of your intuition, you will not be able to come out of the maze. So you have to make one rule at that time, that whenever I reach an intersection, I will either go left or I will either go right. That is the only way you will come out of the maze. Because what will happen is that if you take a left and then you reach a dead end, right, then you will take a U-turn. So again, when you reach the same junction, no, it will then take you to a different path. It will not make you go again in the same path. Because what will happen if you let's say go again in the same path, again you will encounter the U-turn and again you will come back in the same path, right? So that is the whole idea about behind this algorithm. So I think better you can go through this LSRB algorithm on the internet and you will be able to understand it much better. Now the construction steps and all are fine. Okay, I think yeah. Let me go a little bit on the PID control because this is something which I want to actually cover in today's session. Now you'll ask me why, but I'll tell you. But before that, let me open a whiteboard. Okay, so till now, so Samiksha, you have any question? I see some hands up. Okay, no problem. So till now, what you have seen is that you have a robot and you have two sensors here, let's say, and you have a line here. So now what happens is that whenever this line reaches this, say sensor suppose reaches this position and it sees a line, it tries to make the robot turn in this direction. So what will happen is that when a robot turns in this direction at a constant speed, let's say your robot was moving at a 30 centimeter per minute. Let's say this is the speed of your robot, 30 centimeter per minute. And let's say if it is going to take a turn also at the same speed of 30 centimeter per minute, that will give a jerk to your robot. And when the robot will get a jerk, so what will happen is that first the robot will move this way and suddenly it will try to come this way. So this sensor will not be able to give a very proper value, and this much fast the robot will move, your microcontroller will not be able to understand, because very fast the 1 and 0 shift will happen in the sensor. Your microcontroller will not be able to understand what to do. So that is the time when there is a high chances that your robot will miss the line. And once your robot miss the line and let's say come here, then it is going to be very difficult for your robot to again find this line and come back here. So the first and the foremost idea of building a line follower robot is that your robot should not miss the line at all, because once the robot misses the line, no, it becomes too much of a task to again find the line. So the first idea is that a robot should not miss the line. So for that, what you need to do is that whenever a turning has to be made based on the line, the robot speed should go down. Your robot speed should go down so that sensor is able to detect the value much better. Okay. So for that purpose, what we do is that there is something called as a PID. So that is called as a proportional integral and differential. Proportional integral and differential. So what it means is that your robot, let's say the robot has to go through this kind of line. So your robot at every junction, means at every curve, your robot adjusts its speed. So at every curve, the robot adjusts its speed. So how it does is that, so there's a formula called as a, so we find the speed of the robot. What's the speed? Speed should be like Kp into Kd into Ki into your speed, the final speed. So this Kp, Kd, Ki, so these are the parameters for the proportional, integral and differential, the constant for this. So this Kp, Kd and Ki helps you find out that what is the curve, what is the angle of curve here. Depending on that, you reduce the speed of the robot. Reduce the speed of the robot depending on this curve. So now I'll tell you practical example of this. So when you ride a bike or when you ride a car, right? So at a U-turn or at a left turn, when do you make your speed much lesser? At a U-turn or at a left turn? When do you make your speed lesser? So can anyone tell me? If your car has to take a left turn or your car has to take a U-turn, so do you take a U-turn also at the same speed as the speed you take a left turn? Or let's say somewhere steep left turn is there, somewhere broader left turn is there. What do? You adjust your speed accordingly, right? You accelerate or decelerate accordingly, correct? So that is the whole purpose of a PID. So that in order to have the smooth movement of your robot, we make use of the PID algorithm. So in a PID algorithm, what we basically do is, as I told you that we make use of, so for the PID algorithm, so first important thing is that we will not be able to do it with only two sensor. We need to have minimum three sensor or more than three. So the first idea is that we'll make use of 5 sensors, and to each sensor we'll assign some weight. So this sensor will be weight 0, this will be weight 100, this will be weight 200, this will be weight 300, this will be weight 400. So now what we do is that we add the weight of the sensor with some number. So what is this? So when we, let's say this sensor is on a, black line, it is a black. Let's say these three is a black. So for the black, let's say it is 1. What happens? Your value become 200 plus 300 plus 400. So it becomes 900. So if the value is 900, so what it means is that your robot should be taking a right turn at some speed. Now let's say this sensor is not black. So this sensor is not in black. Let's say this sensor is white only. So your value is now 700, 400 plus 300, only this to 700, right? So that time it should take a slower turn because it knows that I can able to be on the line even if I take a slower speed of turn. At this point, when it has to take when all these things are black, so what it means is that it is mostly in a right turn kind of a thing. So at this point, it has to take a more turn to come back to the line. And whereas in this case, yeah. So that is the idea about the PID. So one second, let me show you some video so you'll understand like how does the PID impact. How does PID impact? Let me open some YouTube videos. It's not opening. Second. I'm not able to share that video here. Apps. No. Basic, advanced. Basic. Okay, I'm not sure what is happening, but yeah, you can check for some YouTube videos between PID based line follower and a normal line follower. So what you will see is that the normal line follower will be giving some jerk going here and there, whereas the PID will go very smooth. So that is what you can. So, but the first thing is that first you have to start with the basic one only, and then you can make a PID thing. The beauty is that you don't have to change any of your component. So with the same component, just by changing the program, you can make a PID based line follower or non-PID based line follower. So that is the thing. So I think yeah, that is all for today. So any follow-up, if you want any follow-up session for let's say 1 hour or half an hour on this, but only after you have grasped some of the basic concepts, then we can still have it. So now it's time for the Q&A. So this time I really want that I want some good questions from you people because that gives me a feedback for the next session that we're going to conduct. Let me do one thing. The chat window. Okay, Pawan, you are the moderator for today, right? From the college. Hello, Pawan, can you hear me?
Yes, yeah. Yeah, I'm the moderator for.
Yeah, Pawan. So I want a few questions, man. Yes.
Sure.
Yeah.
It was actually a very nice session today. We got to know a lot from today's session. So, yeah, I would like to ask my friends to first ask about the questions, then at the end, I'll be going on with that.
Yeah.
So, guys, if you have any doubts, you can please ask the mentor, Pratik sir. So, yeah, please go on.
Hello, sir.
Yeah. Let me-
So, what are the sensors we used here for the
Yeah.
robots?
Yeah, for the robot, we're using proximity IR sensor. So as I explained you how the proximity IR sensor works. So it works on the principle of reflection of light. So basically, you have a IR LED there and a photodiode. So IR LED emits the light, and photodiode receives that light. So this is the sensor that we use here, proximity IR.
Mm. Okay, sir. Thank you.
Okay, so let me ask one thing. So how many of you are interested in participating in this event? Can you unmute and tell who all are interested in participating in this event?
Sir, I'm interested.
Okay, what's your name?
Samiksha.
Samiksha. Okay, yes, Samiksha. So, yeah. So, if you participate in this event, so you know the procedure. How do you participate in this event?
Sir, actually, I'm from a different college. I'm
Mm-hmm.
from Bangalore College.
Okay.
So, is it like we have to participate with our college mates, or
No,
we can participate?
no, you can participate in a different with students from different group colleges as well. So the thing is that you can have a team of two or more than two members. So up to four members team can be there. So each
Yeah.
one of you who are participating have to first register in the techfest.org website. So once you'll register, you'll get a team ID. So after getting a team ID, what you have to do is that you have to again go and join a team. You have to join a team. So where you can give the team ID for each of the member, email ID for each members, and then that will make you a team. So you can do that. So
Yes, sir.
yeah.
Yeah.
So please do that because this is I would request everyone to please participate in this event because it is one of the most prestigious event. So first you will have the journal round. Once you have selected the five team who are selected from the journal round, will have the chance to go for the Techfest IIT Mumbai. Anyone else who is interested?
So,
So few names.
actually, many other people are interested. Some of them couldn't attend the session. So, I just thought I'll be sending the PPT to them.
Yeah.
And
So
even I wanted to participate, but the thing is that I'm busy with the TechFest event organization, and also
mhm.
next year I'll be participating with this.
Okay. Okay. No problem. So at least means like out of how many members are here total? Where do we see the number? Once again, let me stop the share. Then I think I'll be able to see the number and all. Okay, so I see 21 here. So out of 21, at least 50% count also we take. 10 members should be participating. That is what my belief is there. Because unless and until you participate, no, you'll not get much idea. Even if let's say I conduct a 4-hour workshop session also, right? That will not give you any idea unless and until you try it. Yeah, Vaibhav, you want to ask something?
No, sir, I'm interested in this.
Yeah, Vaibhav. Sure. So that's what. Please go ahead and participate in this event. As I'm telling that, even if I give you a 20-hour session also, no, that will not give you any idea on robotics. Robotics is something which is once you do it, then only you will be able to understand it. It is not something that you study for 4 hours, 10 hours, and you will be able to get it. It is not that subject. Okay, so I think we are pretty much on time. And thanks everyone for joining the session today. I hope everyone liked it. So what I will do now is that I will one second because I want to actually get a feedback. So how do I get a feedback of the session? So Pawan, will you help me? Means like after the session in getting a feedback?
Sure, sir. Yeah,
Yeah,
I'll
because
ask my friend to create a Google form if you want.
yeah,
So I'll
sure,
forward it.
sure, sure. Because that will really help me to understand like which area I have to improve and what topic I have to give more stress to.
Yes, I'll
Okay. Okay. Thanks, Pawan. Thanks everyone for joining the session today. Hope to see you all in TechFest.
Thank you, sir.
Thank
Thank
you.
you, sir.
Thank you.
Thank you, sir.
Bye. Bye.
Thank you, everyone. Thank you, sir.
Thank you. Thank you.
Sir, I'll end the session, sir.
Yeah. Yes. Yes.